the snail problem in your class, right? What would be the mathematics that you'd be addressing, and how would you use it? Okay, so you can. I'll ask you to share on either question. What is the math, or sharing right away to how would you choose to use a problem like this, right? What would be a means or a method for you to potentially use this problem? Okay, what's the math? How might you use this problem? Who wants to give us a few words?
Well, the math is recognizing a pattern.
Recognizing a pattern is part of it.
And developing an algebraic rule.
Recognizing pattern and algebraic rule. How huge are these topics right here?
Right? Enormous.
Huh?
Quite enormous.
Quite enormous. Okay. Writing. How accessible is this problem? What's the prior knowledge that a person needs to be able to succeed basically with that full initial snail problem, which went from a 5-foot pole to a 7-foot pole, a 28, 100, and then an M-foot pole? How accessible is it? What's the prior knowledge that a person needs to be able to succeed with this problem? Reading, I heard somebody say reading comprehension.
Very much so. And being able to recognize the pattern and translate it.
Recognize that?
Recognizing the pattern and translate that into an algebraic expression.
So recognizing a pattern, is that something that they have to have prior, or is this in a sense part of the process of building that skill, right? We can think about that part of the process, so we can think about it in two ways. We can say, well, the kid who's stronger on that already might kind of whiz through some of this. The kid who needs some work on this, maybe this is still a little bit accessible. Like, were they able to answer the question on a 28-foot pole? Some of your students, you could be assessing with this. How many of them ended up just drawing a line that was 28 spaces tall on their notebook paper and kind of did it the other way, right? So that's an interesting thing potentially for us as teachers to capture. Okay, we could be using this problem to say, you know what, I want to kind of see how they tackle 28 and then what they do on 100, right? It's interesting to kind of keep watching the kid who's not jumping to pattern for 28, what are they doing on 100? Right? So this could be a nice assessment for us to see, where are my kids on this? Okay, what does it mean if 28 and 100 are things that they just need to kind of draw out and they don't feel a motivation or a reason to seek a better route? Okay, so there's a good opportunity to assess. Okay, what else? What else? Yeah.
Representing data using different tools such as table, equation, graph.
Tables, equations, graphs. Oops. Right? Okay, we can see that playing roles. This is kind of a cool option that we didn't watch other than kind of listening. We didn't see other than listening to you kind of share it, right? But that makes sense to let them see that, and we could think of ourselves. We could do this problem with a bunch of 5th or 6th graders, or we could do this with 8th and 9th graders thinking about getting to issues of slope and representing an equation, right? And then we can do it with our 12th graders who struggled with that mathematics, right? Okay. Other comments to just kind of share. Counting. Okay. Counting, and I'm going to say connecting to that maybe is that issue of where do they start on this pole when they're counting. Do they end up going 1, 2, or do they go 1, 2? right? So how do we label that topic? It's counting, that works. But it's actually a distance. Is it actually as much about counting versus distance? And it again, I heard somebody kind of say this also has to do with units, right? But that issue and capturing it for students so that they can kind of see it a few different times is a really important one, right? They struggle with that. And when we could be talking about adding integers on a number line, and they run into this problem in the same way there, right?
But moving in both directions as well.
In both directions they may struggle, but they may also, if they're going 3 forward, if they're somewhere on a number line and they're going 3 forward, do they go 1, 2, 3? Or do they go 1, 2, 3? Right? Some of them end up struggling with that. They see a number here, you know, they see a number here and a number there. So that's 1, 2, 3. Right? It's a big issue for us to help them notice the error, capture the error, understand why distance and yeah. Oh, okay. Okay. Any other? Andrew can go to the next one. Actually, we're going to go to the next. We kind of talked about that. Okay, let's skip to the next. Okay, so what we're going to do right now is take another shift. So we'll love to hear kind of as you go whether you find the snail to be a useful problem, how those non-routine problems are working out for you. It could be interesting for you to hear things like, how many of you did the consecutive sums problem? Some of you did, but most of you did not, is that right? How did it go? How did it go for you?
It was interesting. I think we spent a couple days on it.
Yeah.
The kids really got into it.
You got into it? Okay. How did it go for you?
Some students really forgot the idea of consecutive integers.
Sure.
So that became a
They had to
clarifying
work on it?
point.
Mhm.
Yeah.
They had to review that, the word consecutive, right? It's a little more familiar than conjecture, but it's still foreign, right? Okay, so we're going to jump into looking at a few sample problems for chunk 2. Okay, so just so you know, chunk 1 in algebra is Amazon Island and planet Krypton. So you kind of, it's order of operations, it's a little bit on properties, like understanding what those are about. Okay, that's a little bit of chunk 1. It's very short. So we're sampling a little bit in chunk 2. Jacob has 84 cents in his pocket. He only has dimes and pennies. Use some guess and check to find the number of pennies Jacob has if he has D dimes. So that's the problem in a sense at the end of it. Okay, go ahead and work through the first few problems. Think about how might your kids work through this?
Is that
Okay.
a typo at the end? If he has P dimes?
If he find
The
the
last
number
one.
of pennies, P, if he has D dimes.
So at the bottom, it says,
Oh yeah, that would be a typo, thank you.
okay.
Okay, so let's, just to help ourselves, can we call it a D? Maybe Andrew will fix it on the spot. That's probably an error in the material as well, I would suspect, because I think this has been copied from it, okay? Oops. Okay, 84 cents.
84 cents.
What error?
What error are you talking about?
I just rotated it.
There we go. Right, that's what it was.
180-degree rotation, that's all.
Sometimes I write upside down. I forget. As teachers, don't you write upside down sometimes? Yeah. but